Hello friends, welcome to the another tutorial of basic electronics module. Now in the previous lecture we have seen the logic gates and before that we have seen the transistors. So in this particular section what we are going to do is we are going to combining both the theories, means the theories of transistors and theory of logic gates into a practical. So yes, in today's lecture, we are going to learn that how you can make the logic gate circuits using some truth tables and your basic information about transistors. So this chapter is particularly for practicals. So in this section, you will learn different activities. This particular session or chapter is divided into four different parts. In first part, you'll be introduced to the activity, like how we are going to do these activities. In the second part, we will see how to make a NOT gate using transistor. Then in the third part, we will see how to make OR gate circuit using transistors. And in the fourth and last part, we will see how to make AND gate circuit using transistors. So first, let me introduce you with the activities that what we are going to do today. So we will first see that how can you form logic gate circuits. So today we will make logic gates, AND gate, OR gate and NOT gate circuits using NPN transistors. So here we will learn how to make these gates using transistor. Also, you will learn that how you can make this kind of circuits on tinkercad software, just like we have done in some previous lectures. So we will be learning on breadboard, also how to make the circuits in tinkercad also. So the several basic logic gates. So the three main basic logic gates which performs the typical logical operations are: first is OR gate, second is AND gate, and the third one is NOT gate. These are the three basic logic gates, and using these three gates and combination of them, you can make several other gates. Now in this particular section, we will make about three gate circuits which gives output similar to OR gate, similar to OR and not logical operators using NPN transistors. Means we are building a circuit using NPN transistors, and that particular circuits will give you output as a OR operator. Means whenever two of them are on, you will get output as on, or either of them is on, you will get output as on, and as AND logic operators, and similar to NOT logic operators. So this kind of you can say this kind of logic gates are used widely in some real life applications also. So first we will see components, that which kind of components we are going to use today. So this is the brief introduction to the components which we are going to use to build our circuits. First and the main you can say the main component or main ingredient of our today's circuit is transistor. So you can say this is the um, heartbeats of our circuit. So, a transistor is a semiconductor device used to amplify or switch electrical signals and power. So, in this particular section, what we are going to do is we are going to use a transistor as a switch. A transistor is one of the basic building blocks of modern electronic circuits, and transistor is used as an input device. So similarly, here our transistor is used as input device, and according to the transistor's state, it will turn on or turn off your LED, which is your output device. Now, second one we are going to use today is resistors. So we know that a resistor is nothing but used to control the current. So we use resistor simply to protect our components. For example, here are LED from overcurrent. So a resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. So resistor here is used to limit the current flowing through LED. Battery. Now, typical usage of battery is to provide power to the circuit, and similarly in our circuit we are using battery to provide power. Then after, jumper wires. Jumper wires are used to connect all our components like a transistor, resistor and battery and LED with each other. Now LED, light emitting diode. This is also another semiconductor device that emits lights when current flows through it. Electrons in semiconductor recombine with electron holes, releasing energy in the form of photons rather than producing heat. LED is used as an output device. So in our circuit, the LED is output device and the transistor and you can say push button or slide switch, they are input devices. Now slide switch or push button, so they are used for switching purpose to turn it on or off manually. Now let's just shortly discuss about the transistor we are going to use build the circuits. So particularly in this section we are using NPN transistor. So what is an NPN transistor? So first of all, NPN. So this NPN is abbreviation which means negative, positive and negative. As we discussed in earlier lecture that transistors are in different types, and this particular NPN transistor is a type of BJT, bipolar junction transistor. So these NPN and PNP transistor are looks alike mostly, but you can differentiate them like which is which. If you want to identify that which is which transistor, so by seeing the name written onto it, by seeing or by checking the name code written onto a particular transistor will give you identification if it is an NPN transistor or PNP transistor. So here BC547. So this particular code BC547 stands for an NPN transistor. So NPN transistor is nothing but it is a transistor in which a thin layer of p type of semiconductor material is sandwiched between two n types of semiconductor materials. Means this p type of region is sandwiched between one negative here and one negative here, so between two negative layer of semiconductor materials. Now, in particular, this NPN transistor, what happens is emitter is always gets connected because emitter, see, this is the base region, the middle one is, we know that it is base. This is N, this is N. So here is N, here is N. One is emitter, another one is collector. So always your emitter and collector regions are negatively doped, means they have negative polarity or they have majority electrons into them, and the middle one p, which is positive region, is base. So in order to use it as a switch, you'll have to put it this region in forward biasing to operate or turn on the transistor. You will have to keep this in forward bias region. So as we know that this is the negative terminal or the negative polarity, so the emitter of NPN transistor always gets connected to the negative terminal of battery. So it will always go to the negative terminal of battery and this will go to the positive terminal of battery. Now, in this type of transistor, the current flows, or you can say the flow of current is from collector to emitter. So which means that the electrons which are the majority charge carriers always flows from collector to emitter. So this is how your NPN transistor is differentiated, and this is how it works. So this was all about NPN transistor we are using in our circuit. So let's first see the NOT gate, that how you can make a NOT gate circuit using a transistor. As we all know, the Boolean expression for a NOT gate is y is equals to a bar, and truth table for it is when there is a in we discussed this in earlier lecture, that this is the only gate, or you can say a unique gate, which has only one input. Means the NOT gate has only one input and one output. So whenever there is a low, or you can say zero state input A, then your output will be higher or in state 1, and whenever you have input A as 1 or high, your output will be inversed. It will be low or in zero state. So the hardware required to build this circuit is our 9-volt battery, one small breadboard, two resistors, one LED, one NPN transistor, some jumper wires, and one push button. Now we know that this is the schematical representation, and this bubble so shows the inverse phenomena. Now let's see the circuit diagram for this one, that which kind of circuit will we make to get output as a NOT operator. So here, first collect all the components, then connect the negative terminal of battery to the negative rail of breadboard. Then connect the positive terminal of battery to the positive rail of breadboard. Now place NPN transistor into the one module, and now place your LED just just in a way that its anode gets connected to the collector of NPN transistors. So your anode, this is the anode of LED, and this is the collector terminal of your NPN transistor. So connect anode with the collector of transistor. Now connect the cathode terminal of LED with the emitter terminal of transistor. So this is how your LED connection gets done. Cathode to collector, and anode to collector, and cathode to emitter. Now place push button into the bottom middle part of your breadboard in a way that the 2B terminal of your push button gets connected to the base of transistor via a 460 ohm resistance. So use a resistor between base and 2B terminal. So connect the 2B terminal with the base of transistor via a resistor. Now connect the emitter terminal. Now this is NPN transistor. So this emitter terminal will always get connected to the negative of battery. So connect the emitter with the negative rail of your breadboard via a resistor, and this collector terminal of NPN transistor to the positive rail of breadboard. Now connect the 1A terminal of your push button, 1B terminal of your push button with the positive rail of breadboard. So this is how you are going to give power to your push button. So this connection provides your input device or your push button a power to turn on or to perform its operation. So as you can see in the image or circuit diagram, that the push button is not pressed yet. Still your LED is in on condition. So isn't it like the operation or logical operator not? That you haven't given any input yet. Means the input, see here we have used this push button to give input. Means whenever you press this push button means you are giving a signal as high or 1, because as soon as you press the push button the current flows through the circuit, and flowing of current is nothing but you are giving a signal as high. And now in this condition the push button is unpressed, means there is no flowing of current through the circuit, means the circuit has input as 0. So at the time of 0 input the output is high, means your LED is in on state. So this is nothing but the operation of not get, means you are giving input as 0, means you are giving no input such as, still you are getting output as high or LED is on. And as soon as you press the push button you will see that your LED will be turned off. So this is how a NOT gate operates. So this is nothing but the circuit connection steps. So in this particular part, we will see how to make a NOT gate circuit in tinkercad particularly. So first of all, open a web browser and then type tinkercad and then open your account that you have created earlier. Now after that, what you will do is either click on create and then circuits, then you will have a page something like this. So this is your blank new project, or you can say a clear screen in which you will make a circuit for NOT gate. So first of all, just change the name. So we are here we are making this NOT gate, and for that we are using NPN transistor. So I am named this project as non gate and NPN transistor. So first what we will do here is we will collect the components required to make this circuit, which is a 9-volt battery, a small breadboard. Then we will require in a single LED, two resistors, a single push button, and an NPN transistor. So we will take one NPN transistor. First, what we will do here is we will connect the negative terminal of battery to the negative terminal of rail, breadboard's rail, positive terminal to the positive rail of breadboard. This positive and negative connection to the battery with breadboard is done here. Let's just change the color of wire using this particular section. We are using the normal wire and we will change the color of wire through this icon. So negative always black, in positive connection with red wire. Now place your transistor somewhere here, something like this. So these are the three terminals of your transistor. The first one is collector, the second one is or middle one is base, and this one is emitter. Now place your LED here. Then place your push button in this part. Now what we will first do is we will first connect the LED with this emitter, this transistor. So the anode terminal of LED anode terminal of LED will be get connected to the collector. So anode and collector of the transistor, they'll get connected. We will change the color with orange. Now connect the cathode terminal with this emitter terminal. Now from this particular hole to this hole, see, you can see this line of green holes, which suggest nothing but that from this hole to this particular hole, these are vertically connected or internally linked. Also, this represents the LED's anode for each of this hole from here to here. This is anode. So we will connect cathode from here, cathode terminal, to the emitter terminal. See here, this shows that at each and every hole in this line, particular column represents emitter of transistor. So we will connect this LED's cathode with the emitter of transistor. Now change the color of wire here. So we have connected LED with transistor. Now what we will do here is we will connect the base to the push button. Why we are connecting this to push button? I will tell you that the as we know that the base is kind of triggering terminal. If you give a signal, particular signal to the base terminal, it will turn on your transistor. So whenever you are giving a signal to transistor, so it will get the signal when only you connect your base with that signal giver. So here a push button is your input device through which you are going to give a signal to this circuit. That's why we are connecting the push button with the base terminal of transistor. So I will connect the base terminal with the 2B here, with the 2B terminal of this push button via a resistor. So I will change the value of resistor here. Let's just set it 470 ohm. You can keep it in 1 kilo ohm also. So now your push button, it's connected with transistor. Just change the color of wire. So this suggests the base connection, this is collector connection, and this is emitter connection. Now connect the now we have connected the most part of this circuit. We have connected the LED with transistor and push button to the transistor. Here transistor is the kind of mediator. This is your input device, this is your output device, because through this push button you are going to give a signal as high or low, means you are controlling from here. So this is your input device. Whatever input you are giving to circuit is through this. If you are giving 1, then you will have to press the push button. Then and only then the higher, or you can say the one state, will go through this. And as a result, your LED will be turned on. Hence, your LED behaves like output device. And this transistor is used particularly to switch this circuit internally. So it is used as in another switch. Now the push button we have connected here will require some power to function its basic function. So to operate or to turn it on, we will have to connect this push button with a battery to provide it power to function. So what we will do here is we will connect the 1B terminal. Here we are connecting 1B terminal with the positive rail of breadboard to give it positive supply. So let's just connect this with 1B terminal. And I'm changing the color with red because it is a supply cable. So we have connected push button. Now what we will do here is we will connect the emitter. Now we will have to connect the emitter with battery. So for that, this is NPN transistor. So the emitter always gets connected to the negative of battery. So we will connect this emitter with the negative rail of breadboard. And similarly, we will connect, just a minute, we will connect this collector with positive of battery. So I am extending the wire to here. So this will also behave like a collector. So this line is for this particular column is for collector. Now also this column is for collector of transistor. So I will connect the collector with the positive rail of breadboard, and I will change the color to orange just to denote it a collector wiring. This is for emitter wiring and this is collectors. Now the one thing is remaining, and which is that you will have to connect a resistor. First of all, let's see what happens. So I am pressing the start simulation, and see here you can see that LED, this particular phenomenon shows you that your LED is burnt out. Why? Because here you can see in the dialog box under it is suggesting you that the current through LED is 915 milliampere, which is more than its maximum value. Its maximum allowable value for current is 20 milliampere, and now the current through the LED is 915 milliamps, which is more than its maximum value. So to limit this current, we will place a resistor. So we will place the resistor to the terminal of emitter, and then the another terminal of resistor will get connected to the negative of battery. And this is the negative, or you can say this is the ground connection. So we will make it black wire. Now let's see what happens. So here our circuit is completed. Now let's press the start simulation button. Still the current is higher. So we will change the value of resistance. So here let's just press start simulation, and you can say you can see that your LED is glowing. But don't you think it is dim, or you can say it's not in its full efficiency? So let's just change the value of resistor. The main reason of LED in a dim mode is mostly because the resistance in its path is very high. That is why the current flowing through it is low. If you decrease the value of resistance in its path, then you can increase this efficiency or glowingness of this particular LED. So let's just change the value of resistance. I will change it to, so let's change it to 470 ohms. Also this to 470 ohms. Now let's just check what happens. So here you can see that your LED is glowing with its maximum brightness, and this is how the NOT gate of using NOT gate using a NPN transistor you can make. So let's move forward with our third part of this section. In this particular part, we will see the OR gate formation using the components So the hardware required to make OR gate circuit are one 9-volt battery, one small breadboard, three resistors of values particular 1 kilo ohms, two slide switches, some jumper wires, one LED and two NPN transistors. So these are the hardware you would require. Now, as we know, the schematic diagram of OR gate is something like this, that OR gate will have two inputs and it will have one output which will behave like a logical OR operator. So A plus B, which represents the uh, logical operation of OR gate. So this is the diagram for OR gate circuit. First of all, collect all the components required to make this circuit. Now, place the breadboard and battery. Now, connect the negative terminal of battery to the negative of breadboard using black jumper wire and the positive terminal of battery to the positive rail of breadboard using a red jumper wire. So now you have connected your source with the breadboard. Now place two transistors. Transistor 1, this is your transistor 1 and this is your transistor 2. Place both the transistors something like this. First your transistor 1 and then your transistor 2. Now place the LED after your transistor 2. Connect the anode terminal of your battery. Negative terminal or anode is positive terminal, so connect the anode terminal of your LED to the emitter terminal of transistor 2 via a 1 kilo ohm resistor and the cathode terminal of LED to the ground or to the negative rail of breadboard using a black jumper wire. So you have connected the anode and cathode of LED. Now we will connect the slide switches with transistors. Here the slide switches are used as input device and your LED is your output device. Using this slide switches, slide switch 1 and slide switch 2, you will give signal to your circuit, whether it is state 1 or high or 2 0 or low. So slide switches are have two types, common anode and common cathode. This is common cathode type. So this is the common terminal. The middle one is common terminal. So connect both the common terminals of both of your slide switches to the both base of both the transistors. Means your common terminal of slide switch 1 is connected to the base of transistor 1 via a 1 kilo ohm resistor. Means one terminal of 1 kilo ohm resistor is connected to the base of transistor 1 and the another terminal of the same resistor is connected to the common terminal of slide switch. Similarly, use a 1 kilo ohm resistor and the one terminal of same of that resistor is connected to the base of transistor T2 and the other terminal of the 1 kilo ohm resistor to the common terminal of slide switch 2. Now here we are using this terminal 2 to turn on the switch. So connect this terminal 2 of your slide switch to the positive rail of breadboard to give it a supply to turn it on. So we have connected this to the positive of breadboard using red jumper wire. So use red jumper wire to connect the terminal 2 of slide switch with the positive rail of battery. So connect terminal 2 of both the switches to the positive rail of battery. Now in OR gate circuit, the collector of both the transistor are connected together. So collector of transistor 1 is connected with the collector of transistor 2 via yellow jumper wire. And the emitter of transistor 1 is connected to the emitter of transistor 2 via a blue jumper wire. So both the collectors together and both the emitter together. Now, in the last part, connect the collector of transistor 1. Collector of transistor 1 to the positive rail of battery or positive rail of breadboard via a red jumper wire. So this is how your connection for OR gate is completed. Now it's time to see the result. Now whenever you will give a switch as high, means you will turn on both the switches, you can see that your LED is turned on, and either of them is in off state, means either one in 0 and one slide switch is on. Then also you will get output as LED on, and one of them, you can say the switch 2 is in on mode and switch 1 in off mode, also your LED is glowing or you are getting output as high, because this is OR operation. Either of them in on state will give you output as high. When and only when your output is low, when your both the switches are in off state, or both of your slide switches are turned off, then and only then your output will be in off state. In OR gate, this circuit particularly enables the current to flow in either direction, means it has this path to go through LED, and also it has this path to complete the circuit. So it has two parallel paths, and hence in each of the turn on case you are getting output as high. But only and only both the switches are in off state, you will get low output. To create the circuit for OR gate in tinkercad, first open a web browser, type tinkercad and open your tinkercad account. Then click on create and circuit. So you will have a new surface to create your circuit. So first we are going to make this OR gate circuit. So we will change the name of this project by OR gate, and we are using NPN transistor. So we are just writing it as NPN transistor. So I have changed the name of project. So let's just start creating OR gate circuit. For that, let's first collect all the required equipments or components from this component section. We would need a battery, a breadboard to connect all the uh, components with each other. We will mount each of them onto it. Then a single LED. We would require three resistors. In this particular OR gate circuit, we use slide switch. So we would require two number of slide switches. Then in the circuit there are two inputs. So we would require two transistors as well. In OR gate, we have learned in our last session that in OR gate there are two inputs and one output. So to give the input, let's just consider this is input A and this is input B. So we will have two inputs and a single output. So we have collected all the necessary equipments or components for this circuit. Let's just start placing it onto breadboard and connecting it with each other. Now we will first connect the battery with breadboard. Connect the negative of battery with the negative rail of breadboard, and positive terminal of battery with the positive rail of breadboard. So I'll change the color of wire. This would as ground, so I'll use black wire, and this is the supply cable, so I'll use red wire. Now place your transistor here. First transistor, second transistor. So let's just add a comment over here. Here is, let's just write transistor, or I'll write it in short form that T1 means transistor 1. Similarly, this is the second transistor, so I'll write it as T2 just for your reference. Yes. So here are both the transistor I have placed. Now place LED after transistor 2 and just flip their terminals, means first anode and then cathode. Now turn your switches, place them here just below each the transistor. Switch 1, this is switch 2. So you can also say it as input 1 and input 2. So let's just add another note as, just write it as input 1, or you can also write it as input input 1 or input A, the way you like it. And this is your switch 2, so write it as input 2. Okay, so we have placed both the switches here. Now let's just start connecting the different parts together. First, what we will do is we will connect this with this slide switches with base, because base is something you will have to trigger to turn on the transistor. So we will first connect the middle point. See here in the this type of slide switches, there are three terminals available. This is terminal 1, terminal 2, and this is the common terminal. So slide switches comes in two types. First one is common cathode type, or and second is common anode type. This particular slide switch is common cathode type. So in the other two terminals, except of this middle terminal, you can connect this with positive terminal, and in the common anode type, the other two terminals except the middle goes to the ground. Now place another resistor here, something like this. So you have connected the common terminal of the slide switch 1 with the base of transistor 1, and also you have connected a resistor between base of transistor 2 and common terminal of the slide switch 2. So here your slide switch connection is half completed. Now we are using this terminal, or you can use this also. So we use this terminal to turn it on. So we will provide a positive supply through this wire. So we will connect this terminal. You can use either terminal, you can use either this or this. So I am using particular this terminal, and I will provide it with positive supply. So I will connect this terminal with the positive rail of breadboard. Similar for this. So this will go to the positive rail of breadboard. So this light switch connection is completed here. Now what happens in OR gate, that in OR gate, whenever the switches are off, or you can say both the inputs are 0, then and only then you will have output as 0. Here LED is your output device and this light switches are our input. So giving input 0 0 will only have output as 0. So in OR gate, what happens is your collector gets connected to the collector of T2. So connect the collector of T1 and T2 together. So I'm changing the color. So collector of T1 is connected to collector of T2. Now similar to that, connect the emitter of T1 with emitter of T2. So T1's emitter and T2's emitter gets connected with each other. See here emitter, this particular column is for emitter, this particular is for emitter of T1. This for T1, this for T2, connect both of them with each other. And also connect the emitter of transistor 2 with the anode of LED. So LED's anode gets connected to the T2's emitter. Now the cathode terminal of LED goes to negative rail of breadboard, or you can say it would be grounded. So we are connecting it to negative rail of breadboard. So the connection for LED is done. Now what we will do is we will connect this here to limit the current flowing through the LED. Now our negative connection is done, emitter is collected. Now we will connect the collector with the positive rail, collector with positive rail. So this is the supply, so I'll change the color to red. Our connection for OR gate is done. So let's just start simulation and see if there is any error or dim light of LED or anything. So after connecting the collector to the positive terminal of battery, our circuit is completed. Click on the start simulation here. See, you can see that your LED has turned on. If you can see, it is so dim that you can't observe it nicely. So what we will have to do here is the also you can see what is the problem over here is it is not a problem, but you will have to replace the resistance and path. Here the resistance we have provided are so much so that the current flowing through LED is so low and hence LED is dimmed. So just change the value of resistor to 470 ohms rather than 1 kilo ohms. Start simulation. Still, you are not getting that much amount of current flowing through it. Just try it by removing the this resistance and now start simulation. Still, you are not getting that much of the current. So now what you will do here is this LED is glowing because of the you can say reverse bias current, because we have not pressed or clicked input. Here first click onto input 1. So here your slide switches is connected to this terminal, so just slide it over. So you can see that the current flowing through LED is high, so much high, and hence you will have to connect this resistance in between the cathode terminal and the negative terminal of battery. Now start simulation. Still the current flowing through it is higher, so change the value of resistance. As you can see here, your LED is turned on because both the inputs, input 1 and input 2, means slide switch 1 and slide switch 2, both the slide switches are in on mode or in high state or state 1. Now, the OR gate logic is that if one of them is on or in state 1, you can get output as 1 also. So, let's just turn off any of them. So, I am turning off the slide switch 1. So, input 1 would be 0. And you can see output, that you are getting output as 1 even you have turned off a slide switch 1. Now let's just turn off both the switches. So input 1 is 0, input 2 is 0. Both the inputs are 0. So your LED is in off state. Now turn input 1 on or in state 1 and your LED has turned on. So it follows your truth table of logical OR operator. Hence, this circuit is known as OR gate logic circuit using two NPN transistors. Let's start our last part of this particular session, which is AND gate. So in this particular section, we will learn how to make AND gate using NPN transistors. So these are the hardwares or components we are going to require to build AND gate circuit, which is a one 9-volt battery, one breadboard, three resistors of 1 kilo ohm, two slide switches, some jumper wires, one LED and two NPN transistors. So, AND gate. To make AND gate circuit in tinkercad, first open your tinkercad account, then click on create AND circuit. You will have a plain area to make your circuit. So first of all, change the name. So we are making AND gate circuit using NPN transistor. So let's type the name of project over here. Click on enter. You will have a name as AND gate. Collect all the components from component section. We will require a battery, then a small breadboard, one LED, three resistors, two slide switches, because in AND gate also there are two different inputs and only one output, and the main component of our circuit, which are transistors. So these are the two transistors. So first, connect the negative rail of breadboard to the negative terminal of battery and positive terminal of battery to the positive rail of breadboard. So here our supply connection is done, and the supply cable I will change it to red. Now place both the transistors, first T1 transistor, then T2 transistor. Place LED here. Now I am writing here, because this is a transistor one, so I'll write it as T1. So this is your transistor one. Copy and paste a similar. So this is transistor 2 and this is transistor 1. Similarly, I'll copy and paste these two for switches also. This is the switch 1. This would be your switch 2. Switch 1 and switch 2. Now also change the switches angle also and place them just below the transistors. This is S1 and this is your switch number 2. Exactly below, this switch S2, exactly below the transistor 2, and this switch 1 below the transistor 1. For AND gate, first we will finish the connection of switches. So the common terminal of the switches, both the switches, switch 1 and switch 2, will get connected to the base of transistor 1 and transistor 2 respectively. So the common of S1 would get connected to the base of transistor 1, and this common terminal of S2 will be connected to the T2's base. So here the connection for base is done. So change it as green. Done. Base connection is done. But here we will connect the terminal 2 with positive rail of breadboard via a resistor. So connect a resistor. Just I'll have to slightly defer it. So the terminal 2 gets connected to the positive rail of breadboard, and this is the red. I'm just placing it in a right direction. So base to the common of slide switch, this base also common of slide switch, green, this is also green. Okay, so this slide switch's terminal 2 is connected to the positive of breadboard. Similarly, this terminal 2 of slide switch will be connected to positive terminal of battery via a 1 kilo ohm resistor. So this cable is supply cable, so I'll change the color to red. So the switches connection is done here. Now connect the LED, the cathode terminal of LED with emitter of transistor 2. This is your transistor 2, this is your transistor 1. Okay, so the emitter here, this is emitter of transistor 2 is connected to the cathode terminal of LED. Now the anode terminal of LED. Now cathode is connected to emitter. So this anode will always get connected to the positive. Anode only goes to the positive terminal of battery. So we will connect the anode terminal, this anode terminal from here to here. It is the these are the holes provided for anode. So this anode will be connected to the positive of breadboard. So here via a 1 kilo ohm resistor. So I have connected resistor in between anodes, LED's anode and positive of breadboard. So one terminal of resistor is connected to the anode of LED and the other terminal of the same resistor is connected to the positive of breadboard. So here the connection for LED is done. Now here in AND gate circuit, these both are connected in AND formation. So the emitter of T1 connected to the collector of T2. So we will connect this with a yellow cable. So we have connected emitter to collector. Now the collector of the transistor T1, collector of transistor 1 would get connected to the negative, this negative terminal of battery, means here. So I'll change the color. This is collectors and this also is also conductors. So these holes are for collector. Similarly from here to here. These holes are for collector. Now collector is connected to the negative rail of breadboard, so I'll change the color to black because it is a ground wiring. So this is how a circuit for AND gate is completed. Now what we will do here is we will check whether the circuit is in a right operating mode or not. So we will check whether the our circuit is in operating mode or not. So after completing this connection, click on start simulation. Here you can see that both the switches are in off mode, means switch 1 means your input 1 is 0 because we have used this terminal to turn it on or off, and similarly we have connected this terminal 2 with the positive supply, so this terminal is used for uh, on operation. Now for this particular case both the switches are in off mode, means both the inputs, input 1 and input 2, here your input 1 and input 2 in low mode or in state 0. So your AND logical operator 0 into 0 means the Boolean expression I am talking about. The Boolean expression for the output of AND gate is A into B, means whatever your input A will get multiplied with the input B. So here both the inputs are 0 or in low state. So the multiplication of both 0 and 0, 0 with 0 will give you output as 0. So you can see your LED here is in off state. Now turn either of them on. So I am turning switch 2 on, means, or you can say the input B is 1. So AND operate according to AND operator 1, this is 1, this is in high state and this is in low state. 1 into 0 will also give you result as 0, means your LED, your output device is still in off mode. Now try the another either or, means I am keeping the input 2 or slide switch 2 in off mode or in 0 state, and I am turning this switch as on, or input A in 1 state. So in 1 into 0 also your output remains in 0 state, or you can say your LED is in off mode. Now let's turn both of them on, or input 1 and input B in one state, state 1, means 1 into 1 gives your output as high or 1, means your LED you have connected as your output device is in on state or in state 1 or high mode. So this is how your AND logical operator satisfy its truth table here. So in AND gate what happens is you can see that the LED to turn on, there is only one path. From starting from batteries positive, either it has this one path only, means if both the transistors are fulfilling all the requirements of turning on, then and only then your LED will be in on state. It has no other path to flow through. While in OR gate what happens, it has more than one path, hence the current has an option to flow through LED, and hence either of them in on state or in high state will give output as high or on. So this was your AND gate circuit. When and only when your both the outputs are on or slide switches are on, you will have output as LED glowing. In AND gate, the Boolean expression is y is equals to a into b, where a and b both are inputs. So in AND gate what you will have as a result is 1 whenever both the inputs means input A and input B are in on state or in state 1. Only and only then you will have output as high or 1. In all the other three cases, you will have output as state 0 or low. So this is the action of AND operator. Means 1 into 1 will give you output as 1. 0 into 0 will be 0 as output in off state, and also 0 into 1 or 1 into 0 would give you also 0. So this is the schematic representation of AND gate. Here this particular section represents the AND operation, means both of the inputs in high state will provide you output as high. Means A and B in state 1 will give output as 1. So in AND gate or any other gates except for NOT gate, you will have two or more than two inputs. In only NOT gate, you will have only one input and one output. But in all the other cases or in other gates, you will have output minimum 2. You can have inputs more than 2, but the minimum requirement of inputs are 2. So you will have 2 inputs and only one output. This is the circuit diagram of AND gate. First of all, collect all the components. Now, connect the negative terminal of battery with the negative rail of breadboard and positive terminal of battery to the positive rail of breadboard. Now, place both the transistors onto your breadboard, something shown in this diagram. Now, place the switches, switch 1 and switch 2, below the transistor 1 and transistor 2 as shown in figure. Now connect the S1's common terminal or middle terminal with the base terminal of transistor 1, and similarly the common terminal of switch 2 with the base of transistor 2 using yellow jumper wire. Now we are in here using a terminal 2 of both the switches to turn on the switch. So connect the terminal 2 of switch 1 to a 1 kilo ohm resistor. Now connect the remaining terminal of a 1 kilo ohm resistor to the positive rail of breadboard. Similarly, the terminal 2 of your side switch 2 is connected to the 1 kilo ohm resistance, and the remaining terminal of the same resistor is connected to the positive rail of breadboard via a red jumper wire. So this connection specifically provides your slide switch a supply to turn on or turn off. Now place your LED just after transistor 2 and connect the emitter of transistor 2 with the cathode of LED. Now your anode of LED is connected to the positive terminal or positive rail of breadboard via a 1 kilo ohm resistor. So place a resistor something like your terminal 1 of your resistor is connected to the anode, and the remaining terminal of the same resistor of 1 kilo ohm resistance to the positive rail of breadboard using a red jumper wire. Now connect the emitter of transistor 1 to the collector of transistor 2 via a green jumper cable. So connect T1 and T2 with emitter and collector with a green jumper wire. So emitter of transistor 1 is connected to the collector of transistor 2 via green jumper wire, and connect the collector of transistor 1 collector terminal of transistor 1 to the negative rail of breadboard using a red jumper wire. Here your connection for AND gate is completed. Now it's time to see the result of AND gate AND operator. In case 1, when both the switches are in off state, means if both the switches are turned off, then you will have output as LED off, means LED in state 0 or in state low. Press the slide switch 1 on, means your input 1 is in high mode or in high state 1, and keep switch 2 off. So it will give you as a input 1 in state 1 and input 2 in state 0. So you will have output as 0 or LED is still in off mode. Now reverse this, means your switch 2 in high mode or state 1, means turn on your switch 2 and turn off your switch 1, giving input A as 0 and input 2 as high or 1. You will see that your LED is still in off mode, or you are getting output as state 0 or low. Now in the last case, what we will do here is we will turn on both the slide switches, means input A and input B. Both the inputs are in high state. Now you will see that your LED is turned on, means when both the inputs are in on state or in state 1. So 1 into 1 means the multiplication of both the inputs giving you output as high. So this is nothing but operation of AND, logical AND operator. So this circuit follows the truth table of AND gate, and hence this is the AND gate logic circuit using two transistors. In here you can see that you have only one path, means the current have only one path to flow through. It has no parallel path to flow in either direction. Hence this is AND circuit. It has only one path, means it is completing whole circuit in only one path. So current will have no other option to flow through. And this is how your AND gate circuit behaves. And these are the steps if you are creating a circuit using tinkercad. So thank you so much. This was all about logic gates using NPN transistors. So in this section or in this chapter, we learned how you can build OR gate circuit, AND gate circuit and NOT gate circuit using NPN transistors. So this was all about today. We will see you in the next tutorial. Thank you.